So this is probably our last big final big topic to do. That's chemistry in the air, and we're going to first look at the greenhouse effect, which you've probably all heard about in the news and at GCSE and so on. Is the greenhouse effect a good or bad thing, do you reckon? Bad thing? Anyone else think it's bad? Yeah? Yeah? Well, without the greenhouse effect, we would not be here today. The Earth's temperature would probably be around about minus 100 degrees C, which means, what would that mean?
No crops.
Well, where did life begin? Where do you think life began? In the sea. What would have happened to the sea? It would be ice. We would be an icy planet, and it's unlikely that we would have life as we see it today. So the greenhouse effect is actually a good thing, because without it, Earth would be too cold for us. It would be minus 100 degrees C, so it would be far too chilly for probably where we are at them for humans to now exist. However, what's a bad thing? Greenhouse effect, good. What's happening at the moment? What do we call it? Global warming is bad, probably. So why is the greenhouse effect such a good thing? It helps keep us warmer than expected. Why is it? Well, it's because certain bonds, and you'll have a look at this when you do a little bit of more organic chemistry, certain bonds, so certain chemical bonds, absorb IR radiation. The ones that we are interested in are CH bonds do it, OH bonds do it as well, and also C double bond O bonds do it. Those are the ones that we are interested in. Now, where would we find those bonds in the atmosphere? What gases have we got in the atmosphere where we think those bonds would be? I've got a CH bond, an OH bond, and a C double bond O. What molecules? What's the atmosphere made up of?
Stratosphere.
Yeah, no, think of chemical gas. Chemical. Nitrogen's okay, no nitrogen in there, but okay. Sorry? Carbon dioxide, so that's going to be that guy there. So we would find that bond in CO2, because you know from bonding and structure that carbon dioxide looks like that. The next one, OH, come on. Water, yeah. That's in water. This one's a little bit tricky, CH bond. Methane, yeah. How does methane get in the air? Cows. And us as well, to be fair. But maybe. Unless you're such a lady, you don't. Not at this school. Certainly not. Okay, so that is methane. We call these greenhouse gases. Yeah. These are all greenhouse gases because they contribute to the greenhouse effect. And you need to know the greenhouse gases. Okay. So you're going to talk more about how they actually absorb radiation a little bit later on. So I'm not going to talk too much about this, but just so you've got an idea, when we draw molecules, like methane, we draw them like as little static, it's like photos of them, they're not moving, so it's like a photo of us. However, you know that we're moving all the time, yeah? As do molecules. Now, methane and water and carbon dioxide, they're not just moving around, they actually vibrate as well, so the bonds vibrate. So all the time, these little oxygen-hydrogen bonds are vibrating, so if this is oxygen, that is going like that the whole time. What happens is when I shine infrared radiation radiation on it, it absorbs the infrared radiation, gets excited and vibrates even faster, and then it emits it and it goes back to slow. So what's happened is if I shine infrared radiation on a molecule, it gets all excited, go, whee, and then it re-emits it, because it gets all tired, goes out. So that's what's happening. That's how they absorb it. They start vibrating much faster than they were. And you'll talk far more about that when you do infrared spectroscopy as part of the organic chemistry. Right, so this is a very dodgy diagram of how the greenhouse effect works. So we've got the sun. The sun is emitting electromagnetic radiation. The part of the electromagnetic radiation that we're interested in is ultraviolet, infrared, and visible. Okay. So that radiation is whee, and makes its way all the way to Earth. What does it do? What does most of that radiation do to the Earth? It warms us up. So the Earth gets warm. However, the Earth, once it's got warm, it doesn't just keep getting hotter and hotter and hotter, does it? Yeah, it lets it back out, mainly as, what's heat radiation is infrared? So it lets it back out as infrared radiation. Now about 70% of it goes out into space. But greenhouse effect gases absorb the other 30 and re-emit it back into Earth, which is why it stays warmer. It's like a blanket over us. So, you know, you're emitting heat the whole time, aren't you? But your duvet sends the heat back down to you. Some of it still escapes, but without the duvet, far more of it would be escaping out into the room. But the duvet keeps you nice and snug. And so we'll say it comes up. So here we'll say it warms up Earth, warms up the Earth. Let's say it's re-emitted as IR radiation. 70% of it returns to space. Greenhouse gases absorb the rest. Greenhouse gases absorb 30%. And that is returned to Earth, like so. So that's pretty much how the greenhouse effect works. Comes from the sun, re-emitted as IR, 70% of it goes out. Greenhouse gases, methane, carbon dioxide and water, absorb the 30% and it comes back into Earth. So we said earlier there were 3 greenhouse gases that we need to be concerned about. They were methane, CO2 and water. Some of these have a greater effect than others. So some of them have a big effect, others don't have so much effect. So the effect that they have, how good they are as a greenhouse gas, so you can kind of think as like the thickness of your duvet. Some of them are better than others. Some duvets are really naff at keeping you warm, others are better. What does it depend on? Well, can we think of what it would depend upon? Think about what's happening. What do people always say? What's a big problem that we've got? Particularly with this boy here. We're getting... No. What's happening? What's happening to the concentration of this in the atmosphere? It's getting bigger. So the greenhouse effect depends on how much of it we've got. If we've only got a tiny amount in the atmosphere, it's not going to have a big effect. But if we keep pumping it up, it's like pumping extra stuff into your duvet. It's going to have a greater effect, isn't it? So, depends upon the concentration of the greenhouse gas. but it depends upon something else, which you won't know about until you do infrared spectroscopy. Some of those bonds are better at absorbing radiation than others. So C double bond O bonds are really good at absorbing radiation. So it depends not only on the concentration, but how good they are at absorbing radiation. So the concentration of the greenhouse gas and its ability to absorb